So today we're going to keep working with the aptitude scores for kids based on the age they spoke their first month. So I kept the space for us to draw our scatter plot and our residual plot. We're going to be looking at some outliers today. So we are I don't know, maybe you still have your scatter plot saved in Google Sheets. In case not, I'm going to go through it really quick. So, age, aptitude, age, 15, 26, 10, 9, 15, 20, 18, 11, 8, 27, 9, 10, 11, 11, 10, 12, 42, 17, 11, and 7. Aptitude, 95, 71, 83, 91, 102, 87, not 87 plus, 93, 100, 104, 94, 113, 96, 83, 84, 102, 100, 105, 57, 121, 86, and 100. Alright. So, just as a reminder, scatter plot. Highlight, insert, chart, scatter. I don't like where my horizontal starts, so I'm going to go to the horizontal axes, 0 to 50. Looks pretty good. I'm going to move it. Can I not move it? Oh, I just drag. I knew that. Alright, I'm going to just kind of hide it. We'll put it over there for a minute. Alright. Predicted aptitude. So we're going to highlight. I guess let's look back here at this really quick. So, in case you forgot from our last class, if you go to series, scroll down, trend line, scroll down, use equation. There's our LSRL, our least squares regression line, and we need that for our predicted. That's why I brought it back. So predicted, we're going to highlight. We're going to type in the least squares regression. So it equals negative 1.13 asterisk, so that it knows we're multiplying. Our x's, the ages in months, go from A2 to A22. And then, ooh, it put 1 at 10. We're going to use the 109.87 from last class. I'm surprised it rounded, but that was the y-intercept we used last time. Hit enter, it only gives you that one, but then pull down and it gives you all the predicted aptitude scores. Then we're going to do residuals. And remember, your residuals are your actual aptitude scores. So we're going to hit equals. The actual aptitude scores go from B2 to B22. And then we're going to subtract the predicted, so C2 to C22. Hit enter. Drop down. Oops, too far. There we go. So there's our residuals. Then we're going to make the residual plot. So I want age graphed with residuals. So I highlighted age, and then I hold the control button down, and highlight residuals. And then I'm going to go insert chart, scroll up, might be down, mine was down. We're going to scroll up, change the chart type, we want it to be scatter. If you have blue and red dots, make sure that your x-axis here says age, and then make sure your series says residual. Some of them will be blank for the X, and they'll have both here, and it'll look like that. So then you need to, on your X, choose age, and then on the series, you need to remove age. And again, I don't like the way it's set up the axes, so I'm going to go into customize. I want my horizontal axis to start at 0 and go to 50.
Attention seniors,
there we go.
If you missed Johnson's today, you can pick up your items in the activity office. Thank you.
And then vertical axes. Like I said the other day, I don't like that it's uneven, so I'm going to make my minimum y -40 and then my max y 40. And there's our residual plot. So like I said, we're going to be looking at outliers today. We're going to make a quick sketch. Just like the other day, they don't have to be perfect. We're just making a quick sketch of them. So I'm going to draw a line. So my scatter plot's going to be over here. That's the origin. Can't remember what my axes on my y went to. 125. This is 125, and then I made this guy go all the way to 50. So we have some So that's a quick sketch of the scatter plot. Like I said, not perfect. And then a quick sketch of a residual plot. 0, that's still 50. We went up to 40, down to -40. We have something like that. So outliers are an observation that lies outside the overall pattern. There are two possible outliers here. So this one is a little more obvious. That's somebody whose aptitude is relatively low and was pretty old when they spoke their first word. So that was child 18. Our other one, and that's child 18 right there. Our other one on the scatter plot's not quite as visible, but he is a lot more visible in the residual because he's way And so that's this kid who has this really high aptitude that our least squares regression line wasn't very well at predicting. And that's kid 19. He wasn't like extremely young for his first word, so to have a really high aptitude is a bit unusual. So we're going to find the residuals for each of our outliers. So just as a reminder, our equation is y hat equals 109.87 minus 1.13x. So we're going to start with child 18. So child 18 was 42 months old when they spoke their first word. So we're going to put 42 in for x. So 109.87 minus 1.13 times 42. So our predicted aptitude, is 62.41. Their actual aptitude is 57. We want to find the residual, and remember residuals are y minus y hat. So the actual 57 minus our predicted 62.41. So 57 minus 62.41, which gives us a residual of negative 5.41. And then child 19, same thing, we're going to find his residual. So he spoke his first word at 17 months. So 109.87 minus 1.13 times 17, which is 90.66. So we're going to take his actual minus the predicted, and we get 30.34. So child 19's residual is much larger because he's an outlier in the y direction. So everything, I'm looking for my pencil. So if we were to draw a line, now this is not going to be a perfect line, but it's something like this. There's our least squared regression line, right? I actually have it on my scatter plot. Let's see. I want to move that one. I'm going to look at this guy. So see how here's child 18. He's really not that far from our least squared regression line. He stands out from the rest of the data, but he's really not that far from the least squared regression line. So his residual is smaller. Our prediction would be on the line, so it's not that far away. Here, child 19, he's kind of grouped in with the rest of the data, but he's really far away from that least squared regression line, so he's an outlier in the y direction because his y value is very different from our prediction. This guy's an outlier in the x because he's so much older than the rest of the data when he spoke his first word. So outliers in the y direction have bigger residuals. So child 19 has a larger residual because he's an outlier in the y direction. So now we're going to look at which kid has more influence on our least squared regression line. So our least squared regression line right now is y hat equals 109.87 minus 1.13x. So we're going to remove child 19 from our data, see our new regression line. And then we're going to put child 19 back in and remove child 18. So I'm going to go back to my Google Sheets. Excuse me. All right. So we don't need the residual anymore. And I'm going to have to create a new scatter plot, so he's going to go away. So child, what are we removing first? Child 19. That's this, really the kid who's older, the outlier in our X. So if you click on 19, sorry, I'm going to double check. Excuse me, child 19 is this guy. It's off because I have my labels. I'm like, wait a minute. So we're removing the 17,121 first. So you want to highlight row 20. So if you click on the 20 over here, it highlights it. And you're going to go to edit. And you're going to say delete row 20. So then that guy's gone. So then I'm going to find my least squares regression line for my age and aptitude now that that child's removed. So I'm going to insert my chart. I'm going to scroll up, tell it to use a scatter plot. Maybe. There we go. I'm not going to worry about my axes right now because I'm more interested in my trend line. So go into Customize, go to Series, scroll down, choose Trend Line, scroll down, tell it to use the equation. So we get negative 1.19 for our slope and 109 for our y-intercept. So I'm going to jump back here. I'm not going to put that in there. So with child 19 removed, we now have y hat equals 109 minus 1.19x. So didn't change the y-intercept much, didn't change our slope much. So now we're going to remove child 18, and that's the 4257, and I need to put child 19 back in there. So back to our Google Sheets. I'm going to get rid of that. So I want to replace the 4257. I want to put the other child back in who spoke his first word at age 17 months with an aptitude of 121. So that time I didn't delete a row, I just replaced my data. Highlight, insert, chart, insert, chart. There we go. I was like, wait a minute. Change it to a scatter. Again, not worrying about my axes. Going to Customize, go to Series, Trend Line, Label, Use Equation. So now we have negative 0.779 times x plus 106. So if we go back here, new equation with child 18 removed is 106 minus 0.779x. So which child had more influence on the least squared regression line? Child 18. The y-intercept, still not a huge change, very big change in the slope. So child 18 had a bigger influence. And the reason why is because he was an outlier in the x direction. So he was this guy who had a really small residual, so our least squared regression line, he directed our least squared regression line. We get rid of him and suddenly there's not as much linear shape, it's kind of flat here. So child 18 is an outlier in the x direction. So outliers in the x direction really mess with your least squared regression line. outliers in the X direction are the ones with smaller residuals, because they're helping keep the shape of our least squared regression line. And then we're going to just do a couple true false. So true or false, knowing which variable is explanatory and which is response is important for regression. That's true. Correlation and regression lines describe the strength of any scatter plot. So lines, any scatter plot, that could be a curved scatter plot. So this one's false. A line is not going to give us a good measure of the strength of the curved scatter plot. Correlation and regression are resistant to outliers. That's also false. I talked about that when we did regression lines, and that's what we just showed. The y outliers in the y direction. I don't know where I put that piece of paper. There it is. So outliers in the y direction didn't change much, but it still changed. Outliers in the x direction, big change, so that they are not resistant to outliers. And then high correlation means that one variable is causing changes in another variable. That's false. Correlation does not imply causation. So in your homework, you're going to do a couple problems about outliers and then finish with some multiple choice questions.